So we're going to look at questions to do with statistics, questions to do with probability, and we'll also tackle a few questions to do with probability distributions. So under statistics, there's what we call the Chebychev theorem, which applies to all data distributions, where we are told that at least 1 over k squared of the data will fall within a standard deviations away from the mean. The empirical rule, on the other hand, gives a guideline that follows a normal distribution given by confidence interval is equal to a mu plus minus a z standard deviation. So it is also known as a 68, 95, 99.7% rule. So it assumes that 68% of the data will fall within 1 standard deviation, and 5% of the data will fall within 2 standard deviations, and 99.7% of the data will fall within 3 standard deviations. So knowing this Chebychev rule itself will now help us look at how questions come in that line. So we'll quickly go to our test question. Question number 1. We're told that the mean monthly mortgage paid by owners in a town is given by 2365 with standard deviation 340. Use the Chebychev theorem to find the percentage of homeowners in this town that pay monthly wage of between 1685 and 3045. So we just mentioned to say Chebychev is given by confidence interval is given by mu plus minus k standard deviation. So in this case, we've been given our mu as 2365, our standard deviation as 340. Now, without being given, we must understand that the confidence interval has both the lower bound and the upper bound. On the lower bound, we've been given part 1 of the question to say, find the percentage that will lie between 1685 to 3045. So 1685 to 3045. So 1685 to 3045, our lower bound. And this is our upper bound. So lower bound is simply equal to what? Mu minus a sigma. Upper bound is simply given by mu plus k sigma. Can use any of them. So lower bound is 1685, and our mean, which is our mu, is given by 2365. Then our standard deviation is given by 340. So in this case, you have to solve for what? K. We make K subject to a formula. So we're going to have 2365 minus 1685. So this will give us 680. When you divide both sides by 340, and our K therefore will be 2. We're being asked to calculate the percentage that will lie between 2 standard deviations in this case. So we're going to say, since the Chebyshev rule simply says find the percentage that lies, we're going to use that formula. So if you're substituting a 2 there, we're going to have 1 minus 1 over 4, which is 0.75. So this simply means that 75% of the data will lie between that confidence interval. All right, so it simply means that calculate that, whether you use the lower bound or the upper bound, going to get our K as 2, and the 2 represents that 75% of all homeowners in this town will pay monthly wage of $16.85 to $30.45. That is using the Chebyshev rule. The second part was asking us to compute the interval for which we are 84% at least. So 84%, we know that we need to calculate our K first. So 1 over K squared should be equal to what? 84%. So 1 minus K squared should be equal to 0.84. So when we compute and solve for K, we're going to have 0.16 is equal to 1 over K squared. So you cross multiply, K squared is equal to, swap positions there, 0.16. Then we divide 1 divided by 0.16, we're going to get 6.25. And 6.25 if we're going to find the value of K, we square root it. It will give us 2.5. Now, what is the confidence interval for Chebyshev rule? Mu plus minus what? K sigma. For 340, what is our mu? The question, our mu was 2365 and standard deviation was 340. So since we found our K as 2.5, we're going to substitute here. Our mu is 2365, our K is 2.5, and our standard deviation was 340. So the lower bound is 1515, the upper bound is 3215. So what does this mean? It means that the interval that contains mortgage payments at least at 4% of the homeowners will lie between that confidence interval. That is when we're using the Chebyshev rule. Are we following?
Yes.
So part B, we now want to look at the empirical rule. And the empirical rule is simply given by confidence interval is equal to mu plus minus z standard deviation. So here we're told that the speeds are normally distributed with a base shaped, given our mean is 72. So mu is what? 72. And we're given standard deviation is 3. Is 3. They're being asked what percentage will lie between 63 and 81. 63 and 81. So confidence interval is equal to what? Mu plus minus z, which is equal to what? 63 and what? 81. So mu in this case is 72 and standard deviation is 3. 72 plus minus z is what we're looking for. Okay, so this should give us what? 63 or 81. So if you're using the minus, the 63 must be equal to what? The minus 72 plus or minus z and we have a 3. So here we're going to use just a minus because it's a lower bound. Using the upper bound, 81 should be equal to what? 72 plus z, then here put a 3. You still get the same answer. So when this one comes there, z3 is equal to 72 minus 63 is equal to 9. Divide 9 divided by 3. So our z therefore is equal to what? 3 standard deviations. So there's a song that we have under empirical rule. Number of standard deviations, we have 1, 2, and 3. Percentage for 1 is what? 68%. For 2, 95%. And for 3, 99.7%. So this 3 therefore implies that we have 99% of the observations will fall within that speed limit. So what percentage of all vehicles will have the speed limits of 63 to 81? So after itemizing that data, we found our Z to be 3. So we know that 3, using the empirical rule, we can conclude that 99.7% of this data lies within 3 standard deviations of the mean. So we need to master that song. We're together. We need to master that song. If our answer was 2, we'd have said it falls within 95%. 95% of the data lies within 2 standard deviations. 1, 68% of the data lies within that standard deviation. Then the third part, using the empirical rule, find the standard deviation that contains at least 95% of the vehicles traveling in this section of. To start with 95%, our Z is 3. So that being the case, we're going to say confidence interval will be mu plus minus Z alpha. So here, mu is what? 73, 72. Our standard deviation is what? 3. At 95%, our standard deviation is what? Our Z is 2. That is at 95%. So being asked to find a confidence interval. So you can do 72 plus minus 2. Then here we have a 3. So when you get a 6 there, we'll subtract 72 minus 6. What do we get? And 72 plus 6, what do we get? Upper bound 78. The lower bound is what? 66, is it?
Yes, 66.
All right, so that is what we are supposed to do here. So after putting that, you'll find that the confidence interval will be between 66 and 78. Therefore, the interval 66 and 78 contains speeds of 95% of the vehicles traveling on the section of the grid East Road. So basically, that's how the Chebyshev was supposed to be tackled. Question number 2. Question number 1C, we're given data and within 7 marks to draw the box whisker plot. The first thing, we rearrange the data from the smallest to the biggest. Then identify the quartiles. So to find the first quartile, it's a quarter of n. Our n is 20. So if we get a discrete value, you add, for instance, we get 5, you add the 5th and the 60th, divide by 2. If you get 5.1, 5.2, 5.9, you round up to 6. Only when it's a whole number, you just get that number and the next and divide by 2. So a quarter of n, quarter of 20 is 5. So the 5th and the 60th divided by 2. So 11 and 13. This is number 5, number 6. So So you add and average them. That gives us 12. 12 is our Q1. And to go to our Q2, which was median, half of 20 is 10. Then 6, 7, 8, 9, 10. So it means the 10 and the 11th, you average them. So this is 18 plus 19 divided by 2, we get 18.5. Then the upper quarter is 3/4 of n, which is 15. So 11, 12, 13, 14, 15, and the 16th, we average these two. So this is 30 plus 31 divided by 2, which is what? 30.5. So we get the interquartile range, which is Q3 30.1.5 minus Q1, which is 12. So the interquartile range is simply 18.5. Then to find the lower limit, we subtract Q1 minus 1.5 IQR. So 18 times 1.5 is the standard value. Subtract from the 12, we get negative 15. Then the upper limit, Q3 plus 1.5 IQR. So we add 1.5 by 18. We get what? 58.25. So if you're going to get this column between 18 point, negative 15.75 and 50, you discover that it will end somewhere here. All these are within range. These are outside range. So we're going to cap now to say this one is our minimum value of X. And this one is our maximum value of X. These two are outliers, are not within the range. And our Q1 is 12. Our Q2 is what? 18.5. And our Q3 is what? 30.5. So you know you need to draw this to scale. And our 5-point whisker box should have 5 things: the minimum value of X, Q1, Q2, and Q3. And we also have the maximum value of what? X. So what is our Q1? Calculated the Q1. Q1 is 12, 18.5, Q2, and 30.5. 12, 18.5, and 30.5. 12, 18.5, and what? 30.5. These are the quartiles. The lowest value, according to this adjusted picture here, is 3. The highest value is what? 42. We go here 3, 42. What happened to the other two values? These other two values are outliers. So 62 and 65 are outliers. So just put dots. 62 is here and 65 are outliers. Just make sure that you do it to scale. That it makes sense. This is 0. This is 5. This is 10. This should be 12. 15. 18. 20. 25. 30. 5. 40. Put you somewhere there. 45. 50. So it should just make sense there. This is how we draw the box whisker plot. Any questions on how to draw the box whisker plot? And using the diagram, you'll still be able to tell whether it's a what? Left skewed or right skewed. The difference between these two, 30 minus 18 is 12. 18 minus 12, 6.5. So where it's larger, it's skewed to the right. So this is a bigger number, so say skewed to the right. If the 12 was this side, you'd have said it's skewed to the left. All right. Are there any questions so far on this one?
Yes, Mr. Collins. On the skewness, is it skewed to the right or to the left? I don't know, because I think I remember.
I explained that because the rule of thumb that he was using, it was using a different mirror. So what I've explained, as exactly as I said, so if this is larger here, it's skewed to the right. Okay, and also the other clue is you can use a formula where you're going to calculate the skewness, which is given by 3 mean plus median over standard deviation. So when you get the values, you could still tell the distribution that you get a positive 0.9. And this answer you're going to get means that you are skewed to the right since it's a positive. So now that method will now entail you entering the data one by one and finding the mean, the standard deviation. It will take long, and the variance. But you still get the same conclusion that I've just given here, that this is skewed to the right, and this exact value that you're going to find. Is that clear?
Okay, it's clear though.
There's a way he taught it in class slightly.
Question is, the doc had drawn the human being, and he said, assume that this human being is facing you, and then the left hand will be this side on your right, and then the right hand will be this side on the left, assuming that the human being is facing you. So I don't know.
What he thought was correct in his own definition of explanation, it still arrives at the same answer. So I analyzed that. I've just forgotten how it was done, but it still gets back to the same answer if you're going to assume that. It gives the same answer.
Okay.
All right. Then if you're using condition of probability, given question like this. So let me look at the question in the tutorial sheet. But before I go there, just open up probability with the contingency tables. You need to understand that word and means intersection, word or means what? Union. So to simplify your work, usually love to give this example. First thing, your total up, we were going to get 6, 14, the 20, 8, and the 12 here. That's that if you're finding the probability of A, it's simply the total. 6 out of what? 20. So 0.3. Probability of what? B is 8 out of what? 20. So 0.4. Probability X, 14 out of 20, 0.7. Probability of Y, we're going to get 12 out of 20, 0.6. We're simply getting the totals here. 6 out of 20, 14 out of 20, 12 out of 20, 8 out of 20. They ask you the probability of A, B. It means that the probability of A and B. N means intersection. So in this case, if you're finding the probability of A intersection B, go where they're meeting, A and B meet at 2. So the total for everything is 20. So we're going to get 0.1. So with that being said, how do you find the probability of X intersection Y?
X
intersection y, simply say 8/20.
We're going to simply say 8/20. All right.
20.
Okay. Do we agree? So we're going to look at it from where they're meeting. They're meeting at 8, so 8/20. That's correct, which is 0.4. But when you're dealing with conditional probability, for instance, probability of A given B, you go where they meet A and B, estimate at 2, but the total for the bottom guy, total for B is what? 8. So this is going to be 0.25. How about probability of B given A? They still meet at 2, but the probability, the total for A, which is 6, is 0.33. So try to give me what is the probability of X given Y? Probability of Y given X.
Eight
X
over 12.
given 8/12.
So X of given Y, you did what? 8/12. Whereas Y given X is 8/14. Are we together? What do we get? 0.67, 0.57. And when they say probability of A or B, simply means that you're finding the probability of A union B, which is simply given by the probability of A plus probability of B minus intersection of A and B. So we just itemize the data that has been given. What is our A? 0.3. What is our B? 0.4. What is the intersection? 0.1. So here we're going to get 0.6. What we given? So we now try to look at the tutorial sheet on probability and try to apply what we've just discussed here. So if we're given a question like this, and we're asked to say, have Deborah winning, Bob winning, the totals, short and long. And the examiner wants us to find the probability that Deborah wins if she has a short time. So if means given. So this one's given as Deborah given short. So where do they meet Deborah and short? Meet at 4. But the total for short, which is 10. So 4/10, we get 0.4. And here they say assuming is the same as if or when. Assuming Deborah. So given Deborah, determine the likelihood that the match will be short. So short will come on top because assuming is preceded by Deborah. Given Deborah, what is short? So they still meet at 4, but the total for the one which is down, what is down? Deborah, what is the total for Deborah? 20. So 4/20, which is 0.2. And here it's clear, given warm-up was short. So given short, find Bob. So Bob will go on top. So what do they meet? Bob and short. Bob and short, they meet at 6. But the total for the bottom guy, which is S, 10. So 6/10 is 0.6. Assuming the warm-up was long, so given long, find Bob. So Bob will go on top. So what do they meet? Bob and long. You go where the Bob and long meet. They meet at 24. But the total for the bottom guy, the long, it's 40. 20 over 40, which is 0.6. So now events are independent. You multiply the individual events, they should give you an intersection. So Deborah times long must give us Deborah intersection long. So what is our Deborah? Deborah was what? 4 out of 20, which is 0. What? 0.2. First, Deborah was what? 4 out of 50, sorry. 4 out of 50, which is what? What is 4 out of 50? The
0.08.
repeat Deborah. The probability
Isn't it supposed to?
Probability for Deborah. What's the probability for Deborah? The total for Deborah is 20. 20 out of
20 over 50.
which is 0. What?
4.
0.4. That's the probability for long.
40 out of 50.
Which is what? 0.8. We apply 0.4 times 0.8, what do we get? 0.32. And what is the probability of Deborah intersection long? Deborah intersection long is 16 out of 50. So when we divide 16 divided by 50, we get 0.32. So apply these times that. If they're the same, then we're independent. So 0.4 times 0.8 should be equal to 16 out of 50. So they are balancing. So here is 0.32 and here is 0.32. So we can say yes, they're independent. So we can also do the same here. Sedan, SUV, we get the total. This total here, this total 27. Then we go here, this total and that total. And the total up get 60. So they ask us what is the probability that the car is new? New 39 out of 60, which is 0.65. What is the probability that it's a sedan? You go to the sedan total. It's the 3 out of 60, which is 0.55. And also probability that the car is a new sedan. So this is new and sedan. So and is intersection. So what do they meet new and sedan? They meet at 24. Its intersection is over the grand total, 24 over 60. That is how we get it. And here determine the probability that it's either used or SUV. So this is a union set. So you're going to say probability of what? Used union SUV. So plus SUV minus intersection of used, intersection SUV. What's the probability of used? 21 out of what? 60. Plus SUV, 27 out of what? 60. Minus intersection, what do they meet? SUV and used, 12 out of what? 60. And the final answer is what you get as a union. Are we together?
Yes, sir.
So now this takes us to the test. Similar, we're told that we need to calculate probability that the car is new given it's a sedan. So probability new given sedan, you needed to show Bayes' theorem. So this has its own marks that you need to get. New intersection sedan over probability of sedan Mu given Sedan times mu over probability of Sedan. And you get this. But the shortcut is, where do they meet? Mu and Sedan. And mu and Sedan, they meet at what? 24. But the total for the bottom guy is Sedan. Sedan is 33. 24 over 33, which is 72, 72. The next part was asking us to find probability that it is the random cyclic car that is Sedan is new. So here, Sedan, given that it is new, it's the opposite. So it's different from the statement that would say probability that it is a new Sedan. Here, probability that the car that was new is Sedan. So new given Sedan. If you just say new Sedan, as some of you are making a mistake, you're just getting intersection. So it is probability Sedan given new. Those that were using this copy got 100%. But you need to understand where your 100% is coming from. So the new is down there, then here's new given Sedan times Sedan. But all you need to know is that they're meeting at what? Meeting at 24. At the total for the bottom guy is Sedan, which is Sedan, the total is 33. So 24 out of 33. This one, Sedan given new 24, but the total for new is what? 39. So this is 0.615. Are we following?
I've got a question, Mr. Collins. Why maybe you can just go up a little bit. Why are we multiplying by the probability of Sedan?
Why are we multiplying by the probability of Sedan?
Okay, why I'm getting confused is I would just go with the Sedan intersection nu divided by nu. But then if I the first formula has times Sedan, so that's where I need to puzzle.
Okay. So we need to understand binomial theorem, what it states. Binomial theorem concept, which is a fundamental theory in statistics, basically has a mathematical theorem that we need to comply. Are we together?
Yes.
So for us, we need to understand that the mathematical formula that we use to expand the binomial is given as follows. It is given that A given B is given that B given A times A divided by B. So this one here, you just easily write it as A intersection B over probability of what? B. In the actual sense, it stems from what I've given you there. So you need to understand that this expansion has to be expanded for you to end the full max. So the expansion looks like this. A given B should be equal to B given A times A. Whenever you multiply a conditional probability by its base, obviously you get the intersection. So if you have X given Y, to get the intersection, you multiply by the probability of Y. So this would be X intersection Y. If you have A given B, if you multiply this one by its base, you're going to get what? Probability of A intersection B. That's what the rule says. So when we are assigning probabilities, we need to expand these aspects to verify and prove our theorem. So that's why we were multiplying in this context. Nu given Sedan times Sedan. It was Sedan given nu, we multiply by nu. These must be the same. Have I answered your question?
Yes.
All right. So question number 2. Let's go to question number 3. A researcher at an automobile company had the following. So this is a random variable. So if you're asked what is the probability of getting less than 2, which are less than 2, 0.1 and 0.3. You add these ones, these are less than 2, we get 0.4. They ask you at least 2, is that from 2, 3, 4, 5, then you add all these together. More than 2, you're starting from 3, 4, and 5, you're getting all these. Just to try to explain the preliminaries. Now to find the expected value and standard deviation, it's easy to use the table. So x and the probability of x. The relative frequency is simply the probability of x itself. All together. So in this context, we find the mean. We multiply this by that, we get this. This times that, we get this. This times that, we get this. The total here is called our expected value, which is the mean. So expected value is 1.8, which means that on average, what does this mean? It means that on average, households in this market have 1.8 cars. I.e., this means on average, you have less than 2 cars on average. You get the variance, we square each individual value there to get them here. You multiply this one by the individual probability, this by that, it's 0. 1 times 0.3, 4 times 0.4, and 225 by 0.2. Total there. You see, this is not the variance. If this was our A and this B, to get the variance will simply be B minus A squared. So when you square this and you subtract it from there, what we get is called the variance. Right together. So the variance therefore will be what? 4.44 minus 1.8 squared. That is how we find the variance. And the standard deviation is when you square root that particular answer. Any questions so far? Any questions so far? It's clear.
It's clear.
All right, so we go to the pamphlet. So we did all this in the morning. So we're told that Mr. Gupta got a loan for 150,000 from a nationalized bank. The loan officer informed him over the years that he has received what? 9290 loan applications with a probability of 0.85. So we're being asked, part 1, to find the average in the standard deviation of the loans approved. So this is a binomial normal approximation. I gave you the characteristics of a binomial whenever our sample is more than 30. Just know that we're going to convert that to a binomial norm. Under binomial normal, we should know that the average number, which is mu, is given by NP. Multiply by the number of total applications, which is 2090, times the probability of approval, which is 0.85. So on average, what is the number of what loans? 2482. Secondly, what is the standard deviation? To get the standard deviation first, we need to find the variance, which is NPQ. All right, so our N is what? 920. And our P is 85% or 0.85. And our Q should be 15% or 0.15. So to find this, we square root it. So 920 at 5% and 15%. So you multiply and you square root this. So we're going to get 19.292. So on average, we're going to have what? 2482 loans approved per year with a standard deviation of 19.292. Expect a question like this. Okay. Under sampling, we're told we're given a total number of values as given. And we're told that if the first three in the table are chosen to estimate the average age of the 10, what is sampling error? To start with, the morning we described what is sampling error. This is the deviation of the sample statistics from the actual. So sampling error is simply the discrepancy or the difference that exists in a sample away from the actual population, which comes about because of the sampling error factors. So in this case, that suppose we picked the first three, what would be the sampling error? So we need to first calculate the actual for all the 10. This is our mean for the 10, and for the first three, we find the sample, which is 40. So the deviation population is 40, and the sample, the actual population 37 mean, and for the first three, we just found 40. So 40 minus 37, we get a 3. So sampling error is 3 years. So sampling error is simply the degree by which we miss the mark. Okay. So we're given the customer has an order of 78.25 and the population standard deviation of 22. 90% find the confidence interval given a sample of what? 75 orders. Confidence interval, who remembers the formula? It's simply mean plus minus z standard deviation over square root of n. So our mean here has been given as 78.25. Our z at 90% is 1.64. And our standard deviation is 22.5. And our n is 75. This one came in the May paper. And you're being asked to find the confidence interval between 73 and 89. So based on the sample data, we are 90% confident that the true mean for the orders is between 73.99 and 82.59. The same question, they've just changed the figures here. So now let's try to find for 40 orders. But before, we've been asked to explain the difference in the confidence intervals above. So at 40 and at 70, you discover that we are going to consider a difference in the margin of error. The margin of error is simply given by Z standard deviation over square root of n. So you discover that if you have a larger sample size, it will result in a small margin of error. So we have two intervals and the examiner wants you to analyze them in terms of the impact to have on the confidence interval. You should look at it in terms of the margin of error. Okay. So this is called the margin of error, where you calculate the Z times the standard error. We get the margin of error. So we had a question in the morning. Maybe let me repeat it. We're calculating the value we're going to do the CEO. So we're told that a CEO wants to undertake a survey on insurance policies. The company makes yearly profits, and we're given the mean is 800 and the standard deviation is 300, and we are asked what is the size of the sample size. Okay, what are we given there? What are we given in there? In this question, what are we given? We're given the mean is 800, standard deviation is 300. And we are told that survey is desired to be large enough so that we have what? Reduce the standard error to not more than 1.5% of the population. So we want what? Error. Standard error should be what? Less than 1.5% of the sample mean. Find n. So we know that standard error is given by standard deviation over square root of n. And we want our standard error to be what? Less or equal to 1.5% of 800, which is our mean. So 0.01 times 800, we're going to get 12. So standard deviation is 300. Square root of n, if you don't know. So here we're going to put a 12 there. So we cross multiply. Our n will be this side. So 300 divided by 12 will give us 25. So to find n, we have to square on both sides. So n therefore will be 25 squared, which is 625. So to know the number of policies that we need to make a minimum error of 1.5, we need to have about 625 policies. So how large should sample size be? So this is what was done. 300 root n, 12, when we divide that, we get 25. And square both sides, we get 625. So we need at least 625 policies for us to have a minimal error as stipulated above. Are we together? Are you following?
Yes, Mr. Collins.
All right. So I'll end here for now, unless any burning questions.